Okay, now members, let us see this case when they don't give you the length of the ladder or the rod and they don't give you its weight, but it's also approachable. Okay, a uniform ladder AC rests in a limiting equilibrium. Don't see the point limiting means that friction is at its maximum. With its top A resting on a rough vertical, we expect friction, and lower end C on a rough horizontal, we expect friction also there. If the coefficients of friction at A and C are half and 2/3, find the angle which the ladder makes with the horizontal surface. So they are not giving us length, they are not giving us weight. So we start with that. We say in our solution, we say let the weight of the ladder be W, and let the length of the ladder be 2x. We always want this to be even so that we can easily, when it's a uniform, so that we can easily divide it. So always this will be an even number. Simply 2x, you can let it be 4x, you can let it be 6x, as long as it's even. So now, there we sketch. I am going to be having this going to be my vertical, and I'm going to be having my horizontal there. This is my ladder now. I think you can see it. So this is the point A, so that is resting at the the vertical surface. This is going to be our C. Okay, now we know that there is contact here and there is contact there. We want to see there is contact, reaction. So this is going to be reaction at A, and then this is going to be reaction at C. Any contact, we expect a reaction. Okay, this is an angle because these two are perpendicular. Now, this angle we don't know, and that's called it theta. Remember, this ladder is uniform, meaning its weight is going to act in the middle. So we have also a weight acting in the middle. Let me call this my middle. So this is my W. Okay, now if you have the weight, you don't multiply it by gravity, but if it was mass, we would have multiplied by D. But now we have simplified it, just call it just weight. So we don't multiply with D. Okay, so we have the weight there. That's the difference. If it was mass, multiply with D, but we have weight, that's why I'm going to multiply with D. So remember, now the whole from here, we have 2L. From there, the length of this ladder. From there up here, we have 2L. So we have this as 2L, as simple as that. So we have done with everything almost. But now we have, because these two are rough, we have friction. So I'm going to be having friction at C. But remember, here they gave us the coefficient of friction, because when this ladder is trying in limiting agreement, it means it's about to slide. But when it slides, this one is going the other direction, so friction is going to be opposite. And then this one will go down, so friction is going to be upward like this. So we are going to be having here friction at A, which is going to be, remember always, our friction is given by mu R, the reaction, then the coefficient of friction. So here, they gave us the coefficient of friction as and C, so this one we have it as 2/3, the reaction is RC. Then this one is going to be a half, at A is a half, then this is going to, the reaction here is going to be RA. When you know that, the rest are going to be very easy. So after putting in all that information, what do you think we are going to do? We dissolve. We start with the vertical, and then we dissolve horizontally, then we see if we need to take moments. So dissolving now vertically. Remember, this is the limiting equilibrium. It means that upward forces are equal to downward forces. So upward forces, first of all, we have this. So we have a half RA, then plus also RC. It's going to be equal to this one acting downwards, which is WD. And I call this equation 1. And that's the horizontal forces. We have this one, we have RA. It's going to be equal to 2 over 3 RC. And I call this one equation 2. So instead I have RA, I have RC. Put it here. So it says put 2 in 1. So I'm going to be adding now half RA is now 2 over 3 RC. Then plus RC equaling to W. Can you simplify? So this is going to go with that. So we are having RC over 3 plus RC equaling to W. When you simplify there, so we are going to be having 4. This is 4 RC over 3 equaling to W. Implying that now from here, my RC is going to be equaling to, my RC is going to be equaling to 3W over 4. And I call this equation 3. Okay. Now after having RC, I think we said we can ably get our RA in there. Because we have RC, we can ably get our RA. But our interest is in getting this angle theta. So after having that, what is going to happen? It means that what's going to happen is going to be, we are now going to take our moment. You see, this one is having 2 forces, also this one is having 2 forces. So we can take either here or here. But this one is easier because we see that here it's easier to get the distances, the vertical distance and then the horizontal distance. So it's always better to take moments here because you can see with this force, you can easily get the perpendicular distance. Than taking it here, you can get, but it's a bit harder. Okay, now let us take moments now at C. So taking moments at C and clockwise. You can take them clockwise. Now, and clockwise now, where you are taking moments from, all the forces from there, their moments are going to be 0. So when you see at C, R sees from there and F sees from there. So meaning all those their moments are going to be 0. Why? Because the perpendicular distance, remember moments given by the perpendicular distance times the force. So this is the force, but the perpendicular distance from here is 0. That's why it says 0, and this is going to be 0. And 0 times this is going to also be 0. So it's that this and this, their moments are 0 because we are taking moments there. So with the force surviving, we have this W. So see, if I have that W, you see it's going to act from here. You see it's the force acting downward. So from here, it's going to act anti-clockwise as we are taking there, anti-clockwise like that. So meaning, I'm going to be having W times, what's the perpendicular distance? Now, we need this distance from here up here. So because this was a uniform rod, it means that this one is going to be L, and this one is going to be L. Because we say the way it acts in the middle by uniform rod. So if this is the midpoint, but the whole of this is 2L, it means that this is going to be L and this is going to be L. So I'm going to have now. Okay, so I said here, let our distance be, let our distance be 2L there. Okay. Whew. Okay, now from there now, let us get now, we need this perpendicular distance from here, because you see from C to there, that is going to be our distance there. Now I need this from there up there. So there you draw a simple triangle. This is our theta. So now, you see now, when I base on this, this is going to be, the hypotenuse is going to be L. So, if this is length, now, you see this is adjacent, this is hypotenuse. So meaning, adjacent goes with cos. Then this is going to be hypotenuse. Hypotenuse goes with, the opposite goes with sine. So this is going to be L sine theta. So now, the perpendicular distance now from here up to here, if I have this, from here up to here, it's going to be this. So now, times L cos theta. That's the only anti-clockwise force we are going to be having. So now, this one is clockwise and this one is clockwise. So, it's equal to, why are we using there the principle of moment, which says the sum of anti-clockwise moments are equal to the sum of clockwise moments. So what are we having clockwise? You see, this force here is going anti-clockwise. So its distance from C, you see C can be here, can be translated here. See, now C, I need now this distance. So there you can also use that triangle. If I draw that triangle, now the big one. Now this big triangle, because I need this distance, that's why now I'm going to use the big. Here the length is 2L. So here I have 2L. So you see this is adjacent, so this will be 2L cos theta, and this will be 2L sin theta. So what does it mean? Now the perpendicular distance, I have it from here up to here. I have, this is by RA. So now I will need the perpendicular distance from here up to here. From this point, remember this is R force here. So I need the distance from here up to here. You see it's going to be the distance from here up to here, which is this. So I'm going up now. RA times, now my R, the perpendicular distance is going to be 2L sin theta. Now plus. We have also this FA here. So, or this. So it's that for it, it's acting like that. So its perpendicular distance is going to be from here up to here. But from here up to here, because this is cos and this is 2L, it's going to be 2L cos, as you see here. So we have now FA times 2L cos theta. So now we simplify, this is going to be WL cos theta equal to what is RA. Now we express everything in terms of W. So from here, our RA, I think you can see from here, our RA is going to be, 2 over 3 RC. 2L sin theta. Then plus this FA. Our F, I think you can see it there. It is a half RA 2L cos theta. So our L cos theta is going to be, I have this as 2 over 3. RC is what? My RC is here, times 3 over 4. RC is there. I think you can see it. W times 2L sin theta plus a half. Now, my LA, which is going to be 2 over 3 LA. It's here. 2 over 3 RC times 3 W over 4 cos theta. As simple as that. So, we can every simplify now. Okay, so this 3 is going to go. This is going to be 4. To go with that. So I have WL cos theta equal to WL sin theta. Here what's going? This one is disappearing. This one is also disappearing. So there what is surviving, we have now plus W over 4. Sorry, where did our L disappear from? So L cos theta. Okay, it's like we can divide this by WL by WL. So if I bring this side, I have 1 minus a quarter cos theta equal to sin theta, which I can simply divide the side. So this side I have 3 over 4 equal to sin theta over cos theta. So my tan theta is 3 over 4. And so my theta is going to be, from there, you get your calculator. So you see here, I'm getting 36.87 degrees, and that's going to be our answer with this. So, this is members, that's what we had to do. I wish you well. I see past that. We are done. So that's our answer. So when they don't give you length and weight, don't mind. Always let it be twice L twice X twice P, as long as it's even, so that when we are dividing, I think you see when I'm dividing, it was easier for me to divide. If this was 4L, then it would be 2L, 2L, 6L, 3L, 3L, as simple as that. But even if you use L, this is going to be a half L, a half L, but those fractions are not so good. Anyway, that's it. I wish you well.